Hello. So in today's video, we'll cover a very high level overview of RESTful architecture. So RESTful is an architecture style to develop distributed systems over the internet or over the web. REST itself stands for representational state transfer, and hopefully, as we go through the video, these terms will become what these terms mean will become more clear to you. Rust was first proposed by Roy Fielding in his PhD thesis work, in his PhD dissertation, and it's available online. So if you go Google Roy Fielding, it will take you to that paper, and I highly recommend that you read chapter 5 of the thesis work. Rest was proposed as an architecture to develop distributed systems over the web, over the internet. Now, if you take any kind of architecture, right, whether it's a building architecture or if it's a software architecture, it works within certain limitations, within certain constraints, right? For example, if you take a software architecture and your requirement is to build a system that is accessible over the web, then that becomes a limitations, right? You cannot go and build a desktop application because that's not what the requirement is. So building a web base, building a system that has a web front end becomes your limitation, and you have to design your system within that particular constraint. So these are the constraints that define a RESTful architecture, right? In order to build a distributed system using this architecture, it has to be client server. So there's a client component to it, there'll be a server component to it. So client most likely will be a web browser, and server could be a web service, it could be a web app running, or it could be just a static page, right? And it has to be stateless. So what that means is that any request payload that travels from the client to the server has to be a self-sufficient request. So what that means is the request itself has all the information that the server needs to process the request. So it also means is that the server does not have to maintain or manage any state information about the clients. Now, in any kind of system, right, any decent sized system, there will be multiple components, right? Multiple objects that talk to each other, send messages to each other. Now, in case of monolith applications where all of these components, they're running on the same node, this messaging can happen in memory, right? So not much overhead. But now, if these components are spread over the network, right, in a distributed architecture such as REST, then those messaging needs to happen over the network. Now, this network is going to add latency to your system, right? And how much latency will depend on the bandwidth. It will depend on the throughput, but there will be latency. Now, you can, in a REST architecture, which is a distributed architecture, you can handle this. You can minimize the impact of latency by caching, right? For example, your browser, any modern day browser, has caching enabled, right? It can cache the response, right? Or it doesn't have to be the browser. It could be any of the layers that exist between the client and the server node. The concept of uniform interface is very fundamental to RESTful architecture. Interface concept in REST is very similar to the interface in object-oriented programming. An interface is a contract between client and the server. The interface also hides the implementation details on the server side, right? So as long as the interface does not change, the contract between the client and the server does not change, any changes on the server side, any changes to resources on the server side do not impact the client. The interface in REST primarily it identifies resources available on the server. In case of RESTful, the resources are identified by a corresponding URI or uniform resource identifier. It's very similar to if you have to go to Google, you type http://google.com. So that's a URI to a resource on the Google server, right? Similarly, if you have to call a web service, it's going to have a similar format of URI that you call that will invoke the service on the server side. Now, once a request is made to a resource via URI, the server sends back a representation of the response. For example, if I send a URI requesting information by a user, the server might not send me back everything that it has on the user, right? It might just send me a subset of the data, just a representation of user back to the client in the form of JSON, HTML, or XML. Now, as we mentioned before, there's a contract that exists between client and server, right? Server provides access to a resource to the client. Now, in addition to providing access to the resource, there might be some additional requirements, right? Requirements around scalability, requirements on security. Now you can implement security as part of server implementation, but a good design might be to centralize the security so that all the requests coming in, they go through the centralized security, which decides if the request can be serviced or not, or depending on authentication authorization rules. Now, each layer within this system, now each layer can only see the next layer. So client would just see an endpoint exposed on the load balancer, and load balancer will see client endpoint exposed on the API gateway. An API gateway will have a visibility into the actual endpoint, physical endpoint that's exposed by the server. So this was a very high level and very basic overview of the RESTful architecture. I hope you liked it. If you liked it, please do a like